Alright, so today we're diving into one of the most mind-bending results in math. 1 plus 2 plus 3 plus 4 and so on gives minus 1 over 12. Yeah, I know, sounds cursed. Let's break it down step by step, and yeah, I'll also explain why this result is not as clean as it looks. So let's begin with a classic geometric series. Summation as n goes from 0 to infinity, x to the n is 1 over 1 minus x. And also this is only possible if x, the magnitude of x, is less than 1. Now differentiate both sides with respect to x. You would get nx to the n minus 1 on the left hand side, and on the right hand side you would be getting 1 upon 1 minus x whole squared. Now combine the results, you get the equation. Now multiply both sides by x. So cool, we finally have gotten the summation as n goes from 1 to infinity, nx to the n being equal to x upon 1 minus x whole squared. Now here comes the sketchy part. What if we plug in x equals minus 1? Well, you would be getting minus 1 whole to the n times n inside the input of the summation, which on the right hand side evaluates to minus 1/4. Yup, we're accepting that weird result for now. Now let us define s being equal to 1 plus 2 plus 3 and so on. Well, this is of course divergent. Let's do something clever now. We already accepted that 1 minus 2 plus 3 minus 4 plus so on gives 1 upon 4. Let's just call it a. And now we subtract a from s. S minus a equals 1 plus 2 plus 3 plus 4 and so on minus 1 minus 2 plus 3 minus 4 and so on. It is alternating signs. We group the common terms over here and we get 1 minus 1 plus 2 plus 2 plus 3 minus 3 and so on. This just evaluates to 4 plus 8 plus 12 and so on. Take out the factor of 4 from the summation on the right hand side. You get 4 times 1 plus 2 plus 3 and so on. The summation on the right hand side is just 4 times s. Now we substitute the value of a being 1 over 4. So s minus 1/4 equals 4s. Now I believe you can solve the equation. 3s equals minus 1/4 and s equals minus 1 over 12. Look what we found. That cursed result is back. Alright, now time to come clean. This proof looks super slick, but it's actually kind of cursed. First we plug in x equals minus 1 into the power series. That's only valid when the magnitude of x is strictly less than 1. That's straight up illegal in normal math. And also that subtracting and multiplying of divergent series. Yeah, you can't really do that. It breaks all the rules. But here's the cool part. This weird result is kinda legit, just not in the usual way. See, the number minus 1/12 is actually popping up in real math through something called analytic continuation of the Riemann zeta function. Summation goes from n equals 1 to infinity, 1 upon n to the s. And if you extend it to s equals minus 1, you get minus 1 over 12. And funny thing is, Ramanujan actually messed with this result over 100 years ago. He just wrote this in one of his notebooks, not as a sum, but as a value from a deeper theory. So yeah, the sum doesn't really equals minus 1 over 12. But in certain areas of physics and math, we treat it like that to make stuff work. Anyway, math is weird. That's why we love it. Drop a comment if you want more cursed math like this, and I'll dig deeper. See ya.